This is the instructional video for negative exponents. Now, our negative exponent rule is on our formula chart, just like our other ones, and it is under the properties of exponents, and it says negative exponent. Now, when you look at your formula chart, what it's going to say is that a to the negative n is equal to 1 over a to the positive n. And on our formula chart and in class today, we talked about the fact that negative exponents mean I'm the reciprocal of. So remember, a reciprocal is just when you flip a fraction. So x to the negative 5, like this example that I have here, really means I'm the reciprocal of x to the 5th. Well, the reciprocal of x to the 5th is 1 over x to the 5th. Now, a lot of times students get confused and they think, well, what happened to the negative? Well, the negative is just telling you to move x to the 5th into the denominator. Once you perform the operation, then the exponent is no longer negative, it becomes positive. So 1 over x to the 5th would be the simplified version of x to the negative 5. Those are actually equal. Okay? So let's go ahead and look at this second example. So on our second example, notice we have 3x to the negative 2. Well, this negative 2 only belongs to x. That 3, its exponent is positive 1. So the 3 stays on top, but that x to the negative 2 gets shifted into the denominator, which would make my exponent positive. So the simplified version of 3x to the negative 2 would be 3 over x squared. Okay, let's do some examples that add a little more exponent properties. So here we have raising a power to a power, and we also have some negative exponents that we're dealing with. So you can do this a couple of ways. My suggestion is that you go ahead and deal with the negative exponent first. So I'm going to rewrite this. Since the whole thing, 3x cubed, is inside parentheses, this negative 2 is going to that entire thing. So I know that I can rewrite it with a positive exponent by simply moving the 3x cubed, and then it stays squared, it's just in the denominator. So now that I've moved it, notice my exponent is no longer negative, and now I can use my power of a power rule. So remember, I'm going to give that square to each piece of that monomial. So it's going to be 1 over, and then 3 squared is 9, and x to the 3rd raised to the 2nd. According to my power of a power rule, I'm supposed to be multiplying these, so that would give me x to the 6th. And that would be my final answer. So 1 over 9x to the 6th is my simplified answer. Remember, your answer is fully simplified when you can't do any more math. So my exponent's no longer negative, and I used my power of a power rule. I can't divide, I can't multiply, so I'm finished. Okay, so here's another one. So this one involves division, and we have some negative exponents that we're dealing with. So I'm going to encourage you guys to deal with your coefficients and your negative exponents first. So remember, when you're dividing, you're going to divide your coefficients as normal. So 32 divided by 8 is 4. Now I'm going to start moving things around. So my a to the 5th stays where it is because it has a positive exponent. However, a to the negative 2, I want to make that exponent positive, so I'm going to move it up into the numerator, and that'll make my exponent positive. Then my b to the negative 3 needs to move down in order to make that exponent positive, and my b to the 6th just stays where it is because it already has a positive exponent. Okay? So now from here, I can go ahead and multiply powers with like bases. So 4 stays, and then a to the 5th times a squared, I'm using my product of powers rule, so I should be keeping my base and adding my exponents. Then in the denominator, I have b to the 3rd times b to the 6th, so once again, I keep my base and I add my exponents. And that would be my final answer, 4a to the 7th over b to the 9th. The key here is to take each step and do one thing at a time and make sure that you're not skipping anything, okay? So I started by dividing my coefficients and then moving my negative exponents. So b to the negative 3 moved down, that's how it became b positive 3. And a negative 2 moved up, that's how it became a squared. Then I multiplied last, okay? All right, let's look at another one. So this is kind of a review of a lot of things that we had going on. So notice that I have raising a power to a power, I have some multiplication going on, and then I might be able to divide at the end. So I'm going to start by raising a power to a power. So I know that 3 squared is 9, then x is going to become squared, and y is going to become squared. Then I'm supposed to be multiplying that by 2x to the 4th, y to the 3rd, and it's over 6x to the 8th, y. So all I did was copy this monomial here and this monomial here. Now I'm going to multiply. So I have 9 times 2, which is 18, x squared times x to the 4th, that's my product rule, so I'm keeping my base and adding my exponents. Then y squared times y to the 3rd, I'm keeping my base and adding my exponents, and then I'm just bringing down my denominator. Okay? Now, at this point, there's a couple of ways that you can do this. So, in your mind, what you should be thinking is, I notice here that my larger exponent is in the denominator. So remember, I'm going to kind of pull this portion out to talk about it. X to the 6th means you're multiplying x by itself 6 times. And x to the 8th means you're multiplying x by itself 8 times. When you divide something by itself, it cancels out or it makes a 1. Look at where my x's are left. They're in the denominator. So when I go to divide here, my x isn't going to move up into the numerator like it usually does because my x's are left on bottom because that's where my bigger number was. So now I'm going to divide. Coefficients first, just like I always do. 18 divided by 6 is 3. When I divide x to the 6th by x to the 8th, my x squared is left on the denominator, just like I showed you here. Now I'm going to divide my y's. So I keep my base, and then 5 minus, and remember that's like a little invisible 1, 5 minus 1 is y to the 4th. Okay? And then this would be my final answer. So we have now covered all of our properties of exponents, and we're going to spend a day reviewing this and putting it all together like I did on this problem here. So this isn't the last time you're going to practice all the rules combined, but I'm going to encourage you to make sure you're using your formula chart and you're keeping track of what you're doing and asking questions as you have them. If you need any help, don't forget I have tutorials, and I will see you tomorrow in class. Have a great day.